another short unit. All right? Because I took that one big unit and broke it into two smaller parts. So make sure you have your name on it in the block. All right? So the first half of this unit, which you just wrote the test on, was on adding and subtracting. And today, starting today, we're going to do the second half, which is going to be starting on multiplying and dividing. Right? So you broke it up at the halfway point, adding, subtracting, now multiplying and dividing. Right? And so this is, I think, just 4 lessons. Day 1, day 2, and they're really short lessons. The last day is got some word problems on it, which aren't too bad, and we'll talk about it when we get there. So it'll probably be done in about 2 weeks, maybe 3 weeks. All right? So starting here. Now, so when we are multiplying, we start using exponent laws. All right? So that's what's going to start making things a little bit more difficult. Not that each one of these questions is too hard. It's you can start confusing the stuff you did earlier on in the first half. Right? So going back to September, and when we multiplied things like this, he said, hey, you can combine these as long as the bases are the same. So the bases stayed the same. And what did we do when we're multiplying? Pepper?
You add the 2 numbers.
You add the 2 exponents. The 2 and the 2 make 4. Right? So when we multiply, we add exponents. Right? Now, we start off at the beginning of the year working with numbers because you're very familiar with numbers and you're not very familiar with the letters. But there's usually no real need to do this. Right? If this shows up in like a normal question, you usually do bed math. You don't combine these together unless they really ask you for a power. Right? Yes?
I don't have a computer.
Oh, sorry. There you go. Gavin, do you have one?
Yes.
Yeah. Right? However, starting last chapter, we moved away from numbers and we started using variables, letters. They're just placeholder for numbers. That's where the exponent laws start taking place. And that's kind of the questions that showed up on your MSS math assessment. So, but the rules haven't changed. It just looked really different. So if we had a very similar question, if I go, let's go x cubed times x squared. So the rules are still the same. As long as the bases are the same, you can combine these. The base never changes, so the x stays in x. What should the exponent be in this case? 5. 3 plus 2 is 5. Very similar to what we did in September, and most people did a fantastic job on the test in exponents, right? So I think you guys will do quite well. Same rules, now with variables. And the expressions start looking a little bit harder, right? So if I now do something like this, x cubed and y squared, can we combine those together? Julia shakes her head, no, we can't. The bases are different. As long as the bases are the same, we can combine using the exponent laws. Here, we can't combine that. The base is different. One's an x, one's a y, right? So now, to boost it up one extra difficulty level, what if we go, let's go 5x cubed times 4x squared. Okay? So we're multiplying, think of terms. This one with this one. Like with like. So if we have the 5 and the 4 being multiplied, what number do we get? Gavin?
20.
20. 5 times 4. 20. Okay. Then you move on to the variables. So you look at the coefficients, and you just do the math operation. In the last chapter, the math operation, if it's a plus sign, you add them together, the coefficients, or subtract them. Now, if it's a multiplication symbol, you multiply them. Now we look at the variable. Are they the same? Right? Yes, they're both x's. So now we can use our exponent law. When multiplying, we add. 3 and 2 make 5. Okay? So, filling up our notes. We multiply the coefficients. That's the numbers in front. This is all the terminology coming to play now. And we use the exponent rules for the variables. When we multiply, we add the exponents. Okay? So let's do some quick examples here. All right. So look at coefficients first. First one here. 4 and 2. What do we get? 2 brackets touch each other. It means we're multiplying. 8. Then we have our variables. Are they the same? No. So we can't do exponent laws, but they're still part of the final answer. So they just become x, y. So you take the x here. So this is basically saying x times y. We're just not combining to a single term. Yes, come on in. Okay. Is that fine? All right. So this final answer, what is it saying? It's 8 times x times y. That's what that says. And we combined the numbers we could. We combined the coefficients here. All right. So let's do this again for this one here. So looking at the coefficients for this one. So the coefficients, the number in front, here and here. Multiply them. 2 brackets touch each other. What's the number in front of this first one? Chelsea? You know it. -1. -1. So if -1 times 7, what number do we get? 7. -7. All right. Then we have an x and an x. So the variables are the same. We use our exponent laws. Our exponent law says when we're multiplying, we add the exponents. What's the exponent here? What's the exponent here? Gavin? They're both little imaginary ones. So 1 and 1 makes 2. So x exponent 2. That's it. Right? All right, let's do this one. Going over here. Coefficients. Combine the coefficients. We're multiplying them. What do we get? -2 and -3. What is it?
-2 times 3, right?
Yes, it's -2 times -3, which is a number. What number is it?
+6.
Yeah, +6. Right? That's it. And then we look for our variables. We have an x here and an x here. So the 2 x's are going to come together. So we have x, x5. We add the exponents. 2 and the 3 makes 5. Right? Now we have a y here and a y here. We combine the y's together. What do we get?
y3.
y3. This has a little imaginary 1. Okay? So there's questions like this on your little assessment. Right? You technically could have done them because you sort of knew the rules, but this is sort of like way different than what you saw back in September. Okay? All right. Let's look at this one. And I'm going to rewrite this one. Right? As soon as you have fractions, it's nice to keep the numerators all lined up and the denominators all lined up. Right? So the rules are when we're multiplying fractions, we multiply the tops together and we multiply the bottoms together. Right? So on the top, look at the coefficients. we have a 15, an imaginary 1 in front of that x. So you combine those two coefficients together, what do we get? 15. All right, so this is our numerator we're working with. Then we have our x. In our x, we get x squared. There's a 1 and a 1, so we add the exponents. Then we move on to our denominator. 1 and a 3. 3. 1 times 3 is 3. Okay? Oops. There we go. All right. So, now, the thing is, at the end, we need to check if we can simplify this. So we have a number on the top and a number on the bottom. 15 over 3. Can that be made smaller?
Yes.
Yes. Just a 5. 3 fits into 15 5 times. So 5x squared. That is your answer. Okay? So, what happens now is not that students have troubles with these rules, is they start confusing the rules with adding and subtracting and multiplying. Because you can't forget the stuff from adding and subtracting. Right? So with adding and subtracting, we're going up to the top here, if we had 3x squared plus 2x squared, what's the answer? You guys did this. Combine that to make a like term. What do we get? Are they like terms, first of all? It is. No. Pepper had a 5x2. Want to go to Caitlin?
Yes.
Yeah, Caitlin, 5x2. It's a plus sign. So long as they're like terms, we can add them. So are they like? Yes, they're both x squares. And when we're adding, the variable never changes because they're like. So the biggest mistake is what you just said there. People start changing the exponents here. The 2 and 2 to make that to a 4. Right? No, that's the rule for multiplying, not the rule for adding. And that's what sort of grade 10 is going to feel like, is keeping all these things, none of them very hard, straight in your mind. Because it's going to be like constantly flipping back and forth between all these different rules. Right? Okay. So that is multiplying. The opposite of multiplying is dividing, and which is very similar. Right? So, dividing looked like this. If we have x 5 divided by x cubed, or that can be written as 5 over 3, like this, whatever which way you prefer to see it. Right? I think students make less mistakes when it's written as a fraction. What was the rule for dividing in exponents? We subtract. So long as the bases are the same, right, we subtract the exponents. So use the exponent law. Right? So what would the answer be for this situation? What's the base? What's the exponent? Pepper?
The base would be x and then squared would be cubed. I mean, sorry, squared.
Squared, yeah. X squared. 5 minus 3 squared. That's it. Now, if I put, let's say, 12x5 divided by 4x cubed, or writing it as a fraction, actually, 12x5 over 4x cubed. I think for most part, I'm going to suggest you to write it as a fraction, because you're going to make less mistakes. What do we get?
Would it be 8x2?
The x2 part I agree with. What do we do with the coefficients? We're not subtracting them.
Oh, you divide.
Yeah, you do the math operation. It says to divide. So you divide. 3, right? So we divide the coefficients. So that's the last little part of the notes. Okay. So I'm going to suggest you're going to make a lot less mistakes if a question gives it to you in this format with the division symbol, rewrite it as a fraction. You'll make less mistakes with the adding and subtracting and the coefficients, but it sort of looks like a fraction. The rules become a little more familiar. All right, so let's go like this. First one, all right? Coefficients, just like with multiplying, deal with those first. 4 and a 2. Combine them together, what do we get? 2. It's 4 divided by 2. We get 2. We have an x on the top and an x on the bottom, so those can be combined. What should we get?
I think it's x. Right? It's x.
What's the rule for dividing? What do we do with exponents?
Oh, it'd be x1.
X1. So you can, it's 2 and a 1 here, so 2 minus 1 is 1. So you can put the little 1 in there if you like to, which I know some people did in September, but you don't have to. Remember the ones you don't show. So just equals 2x. That's it. All right? So you just pick off the same thing. Number with numbers, x's with x's, y's with y, and you just do the appropriate arithmetic. Number and number. What do we get? -6 and 3. Are we adding, subtracting, multiplying, dividing? What are we doing with these numbers? What are we doing? Pavitra?
We divide.
We divide, thank you. 6 divided by 3 is 2, and we have that negative sign. Oh, we have an x here and an x here. 2 and a 1. x1, we're subtracting. Dividing, we're subtracting. x1. I'll put the 1 in this time. Y and y. What should the exponent for the y be? 3. Okay, that's it. Okay. So now, if you're given like this, I highly suggest you write it as a fraction. So the first half is your numerator, second half is your denominator. It'll make it a little bit easier. Oops, I'm doing black. All right, and we'll work on the answer here. All right. So, to work with your coefficients. What's the coefficient on the top? If you don't see one, there is one. Gavin? 1. And there's a 3. That can't be made any smaller. Right? So that's going to stay a 3 on the bottom. Right? It can't be taken up into the top or done made any smaller. Okay, so we dealt with the coefficients. Next, we move on to the matching letters, x and x. Combine those two together. What do we get? x2, yeah? 3 minus 1 is 2. Now, where do we put it? Do we put it on the top or do we put it on the bottom? It's on the top. Right? When you do this calculation, it's on the top. Okay? Then, this y has nothing to combine with. So, does it show up in the final answer?
Yes.
Yeah, it just doesn't change. It stays exactly the same. So we had a y here. You just keep the y in the numerator like that. That's it. Okay. All right. Next up. See, this next one's a little tricky. Okay. So walk you through this one. So I'm going to rewrite the first term as a fraction. Right? Now, since the coefficient is a fraction itself, it's a little bit harder than the last one. So I'm going to rewrite this like this. And I'll even put the 1 there if that's helpful to you. So this x cubed here off to the side just means it's part of the numerator. There's no different way of writing it. And then 1/2. So I'm going to write this as a fraction. About the x cubed to the top. Right? Now, remember when we divide, what do? We never divide fractions. What do? Gavin? We don't subtract fractions. Kyan? Yeah, we do the reciprocal. We turn this into a multiplication. We flip that second fraction, goes to the bottom, and this stays on the top. That's a 3 and a 2. All right, that's a horrible looking 3. Okay, here we go. And I'll change that from a red X to a dot so it doesn't look like a variable. I'll change that to a dot. Okay. Now, just like before, when dealing with fractions, combine the numerators, then combine the denominators, and look in between. So, numerators. We just have 1 times this, so the numerator doesn't change. It's 1x cubed. You don't need that 1 in front of there. You can keep it out if you want. Denominators. Here and here. So we're multiplying across. 2 times 3 is 6. X squared. See, now, once you get good at this, you'll be able to go from the first step to this step without showing anything in between. We did it over here. Right? We just took this and we threw it into the bottom. The reason why I didn't do it over here because this one already had something in the bottom, so it made it a little more complicated. But we went to each individual step. But what happened? We take this second part, it becomes part of the denominator. Well, this is already in the denominator, so we just multiply it together. And that's how that flipping reciprocal stuff comes from. All right? Okay, so now we're not done until we've combined everything that's alike. So we don't have to worry about the numbers, because the number can't get any smaller, but we do have an x on the top and an x on the bottom that can be combined. What are we going to do with the exponents? Are we adding them or are we subtracting them? Subtract. It's a fraction, so we subtract. So 3 minus 2 gives us a 1. So, and the 6 stays on the bottom. And that's it. Okay?